Okay? So we are differentiating both sides. Y is a function of x. And when we determine dy over dx, that is the slope. And they're asking us to evaluate it when x is -1 and when y is 5. Is it so far so good? Is it okay so far? Okay, perfect. So the left-hand side is 12x minus. When I differentiate 5 times a function to the third power, I bring down the power. I subtract 1 from the power. And the chain rule is asking me to write times the inner function prime. So -5y to the third prime is -5 times 3, which is -15. I subtract 1 from the power, so y cubed becomes now y squared. And now we have to multiply by the inner function prime, which is dy over dx. At this point, calculus is done. We just have to use algebra to determine dy over dx. I will move this to this side or move this to the other side and divide. It doesn't matter. The answer will be the same. So dy over dx is 12x over 15y squared. Is this step understood? So if you move this step to this term to the other side, you will have everything positive. So 12x divided by 15y squared. Yes, you can simplify by 3 and you get 4 and 5. So then dy over dx equals 4x over 5y squared. All I need to do is just plug in x equals -1 and y equals 5. Before we do that, is this okay? George, is this okay? Is this better?
Yes.
Do you have any questions so far before we plug it in? Please don't be shy.
No, I don't have any questions.
Is this okay then?
Yes.
So now when I plug it in, I get -4 at the top, and 5 squared is 25 times 5. This is 125. So the answer will be -4 over 125. And this is not the equation, of course. This is just the slope. Yes.
Okay.
Of the tangent line to the graph of this equation at this point. Is this okay?
Yes.
Perfect. I'm not only encouraging you to ask questions and stop me. I am begging you. I don't mind imploring my students to do so because it's the only way to learn. To stop me and say, show me another example, or show me why, or show me again, or it's the only way that I can recommend. Okay, are there other questions about this or about anything else that you want to clarify? Anybody, please? Is there anything else? Is there anything else we need to look at? Anybody? Will, do you need anything? We haven't started.
If we could go over a problem that involves the quotient rule or the product rule, that'd be great.
Yes, but please give us one so we answer exactly what you need.
Okay, let me dig through and just find one or two problems.
Yes, absolutely. In the meantime, does anyone else have anything to work with or work on? Any questions? Anyone else? Please don't be shy, please. Anyone, please? Will, do you have it?
I'm looking through my enhanced homework. I'm just trying to find the exact problem here.
Yes, that is the best. The exact question that you have. It's always the best. Does anyone else have anything?
From the 3.6 enhanced homework, it was f of x equals 3x cubed, x equals 3, and then the change of x was 0.4.
So can you say it again, please? I'm sorry.
Yep, it was f of x equals 3x cubed, and then finding x equals 3, and then the change of x was 0.4.
0.4.
Yes, ma'am.
What are we asked to find? Because this is not the quotient rule or the product rule that you mentioned. It's something else, which is fine, absolutely fine. But it's not what you asked for. But what are we asked to do? We're asked to find delta y and dy.
That's correct. That's just one of the ones I had circled.
Excellent, perfect. So let's start with this. So delta y has the formula f of x plus delta x minus f of x, and dy equals f prime of x dx. So these formulas will help us solve the problem. So the x plus delta x is 3.4, and x is 3. So this is just algebra. This is the calculus part, and we're going to solve both, of course. So the f prime, this is 9x squared. So to find dy, I have 9x squared dx. And now it's algebra because I only have to plug them in. So in dy, I have 9 multiplied by 3 squared, which is 9, and multiplied by 0.4. In delta y, I'll come back and write the answer in a moment. I have to evaluate f at 3.4 and evaluate at 3. That's all I need to do. Is this clear so far before we use the calculator to complete the problem?
Yes, yeah, I'm following along.
Okay, perfect. So I'm going to change to the calculator, and here we have in y equals, I will plug in 3x cubed. Oh, 3x cubed. And then all I need is to evaluate at 3.4 and evaluate at 3. So at 3.4 is 1.17, I'm sorry, 117.912 and minus 81. Okay. And then the other one is 81 times 0.4, and it's 32.4. And if you want, 117.912, and you subtract 81. And I get 36.912. And that's final. So delta y is 32.4, and delta y is 36.916, and dy is 32.4. Again, delta y, the exact change in y due to a 0.4 error in x, the exact change in y is 36.912. The approximate change in y for the same error of 0.4 is 32.4. So that's the approximation of this. And this is the exact change. This is done with algebra. This is done with calculus. Is this okay?
Yeah, I followed that.
Very good.
Sometimes to be honest, I just get confused with like what numbers I'm supposed to plug into the change of y formula.
It should not be confusing because you have the definitions, and the definitions tell you what to do.
Mhm.
And of course, delta x is the same thing with dx always.
Got it. Thank you.
My pleasure. Anything else? I thought you had another question maybe, or somebody else has another question. Will, did you have something else for us?
Yes. It was q of x equals x over x squared plus 64.
Q of x equals x over.
X squared plus 64.
Yes, very good. What are we trying to do? What is the question?
I'm sorry, I didn't write kind of what it was asking. I just wrote the equation there. I thought it was asking to find the quotient of the equation.
You mean the derivative?
Yes, correct.
Okay, very good. So in order to find the derivative, in this case, we have to use the quotient rule. The denominator has to be squared, not differentiated. And the numerator has to follow the following steps or sequence. The first function prime, which is 1, multiplied by the second function minus the first one times the second function prime. This is the first function, this is the second function. So one more time. The top prime is 1 times the denominator minus the top times the denominator prime. And then we have to continue simplifying. This is an x squared, this is a negative 2x squared. So I have negative x squared plus 64 divided by x squared plus 64, everything squared. You cannot simplify these, careful. You can only take the negative sign in front and then write x squared minus 64 at the top and x squared plus 64 squared. So this is the derivative of the given function.
Thank you.
My pleasure. Anything else? Ashton, do you have any questions for us? Anything that you need help with? Okay, we can only see his beautiful flags. We don't know if he is here. Ashton, are you with us? Do you need any help with anything?
Yeah, no, I'm good, thank you.
Okay, good. Beautiful flag. Anything else? Anybody else?
I have another question.
Yes, please.
This is from section 3.5.
That's fine. Anything.
Question 2. It's talking about finding the dimensions of an open rectangular box
Okay.
of maximum volume that can be made from a sheet of cardboard, 27 inches by 15 inches. By cutting congruent squares from the corner and folding up the sides.
Very
Find the
good.
volume.
Very good. So we have this XX because they are congruent, meaning they're equal. And then when we create the box, the height will be X. So obviously, if this is 27, when we cut X and X, this will become 27 minus 2X. And this is 15. But when we cut X and X, this width will be 15 minus 2X.
So for the test, would we be able to put those two equations, or we would have to find the exact? Because on the homework, it wanted us to find the exact numbers. That's where I was having trouble.
No. This is the preliminary. This is what I'm explaining, what I'm going to do.
Oh, this is one of the steps.
Yeah.
Okay.
Yeah, good. So we have a, if you'd like to read the problem one more time, just to hear it from the beginning again, to make sure we took everything into account.
Sure. Find the dimensions of the open rectangular box of maximum volume that can be made from a sheet of cardboard 27 inches by 15 inches by cutting congruent squares from the corners and folding up the sides. Then find the volume. And the first part of the question is asking the dimensions of a box of maximum volume are.
And then the maximum volume. Excellent. Good.
Yes.
So now, this is what we are trying to find first. I don't have a function that represents the volume. So then I cannot maximize anything before I get the function. I come back to the box. I created the box. I know the length is this, the width is this, and the height is this. If you go back to our notes, we had a problem like this done in class. Okay, so then the volume, I know it's length times width times height. Meaning the volume now is the length, 27 minus 2x, the width, which is 15 minus 2x, and the height, which is x. Do not distribute x before you multiply these using FOIL, and then you distribute x. So now this is indeed a function of x. So let's stop for a moment. Is this step clear so far?
Yes.
Okay, perfect. George, okay?
Yes.
Okay, perfect. So now I have to distribute. So 27 times 15, 405 minus 30x minus 54x plus 4x squared and then multiplied by x. Good. In descending order now. 4x squared times x, 4x cubed. So this is negative 84. Negative 84x squared because I also distribute x. And then plus 405x. I did get the function that I need to maximize. Now I have to remember what I need to do in order to find the maximum or min, same procedure, of a function. What will be the next step? What do we need to do?
The derivative?
Yes. I have to find v prime, which is 12x squared minus 168x plus 405. Excellent. What do I need to do or find next? In the process of finding the maximum or minimum, I find the derivative and then I have to find
Critical numbers.
Excellent. In other words, I have to just find v prime of x equals, set it equal to 0. So I go to the calculator, I go to apps, it's a polynomial, that's not what I meant. Apps 9, it's a polynomial, its degree is 2. I carefully enter the coefficients, 12, negative 168. What happened? 168. Okay, and 405. And then I get the solutions, and one solution is x equals 3.1, and the other one x is 10.9. Okay. Obviously, I can already say that 10.9 makes no sense, because negative 2 times 10.9, this will be a negative number. Plus 15, this will be negative. So this is not possible. The only possibility is, and everything was given in inch to us, I'm assuming. Was it in inches, centimeters?
Yes, inches.
Inches. So the only possibility is 3.1. for x. I don't know how many decimal digits they want. You know, you have to be careful when you enter the answer. So
They said
2. Oh, in that case, if they said 2, yes, I still have 0, 9 then. So I have to write 0, 9, and the other one doesn't matter. Okay, so x equals 3.09 inches, and I can immediately determine the length and the width. So the length is 27 minus 2 times 3.09. I'll determine that in a minute. And then the width, and we haven't finished though. We also have to find the maximum volume. So, and the width is 15 minus 2 times 3.09. Then I have to show that this indeed gives a maximum. When I look at the quadratic function, and remember the other solution was here 10 point something, and I plug in 0, I get a positive number. And then in between solutions, I will get negative for sure. You can plug in numbers. So this is typical for a maximum. First, I have to find, so I found the height. I have to determine the length. I have to determine the width. And then in the function, in v of x, I plug in 3.09 to find the maximum volume. Is this okay before we switch to the graphing calculator?